Hey TechnoStuds, we've taken a much more in-depth look into the router and how the router routes information. We've talked about routes, we've talked about routing tables, so let's go ahead and revisit that layer 2 and layer 3 walkthrough again. This is a summary of a lot of the concepts that we've learned up until now. So let's see the big picture. Let's step back and see the big picture of how information flows. We know that our routers have routing tables, but remember our layer 3 switch is a routing device as well, and it has a routing table as well. And so does our PC. When we get onto our PC, we can actually do a route print and see all of the routes that are on our PC. So our laptop has a routing table on it as well. So let's talk about how this demo laptop would send, let's say it's trying to create an SSH connection to this switch right here. What would that look like and what would be the process that it would go through? Well, first of all, what it needs to do is it's got to have an IP address. So the IP address of this machine over here, the management IP address is 10.2.0.5. So that's where it's trying to get to. Now what it does is it builds this routing table, and one of the things it will do is it will do a process called ANDing, and it does ANDing with what its IP address is and what its network mask is to figure out what network, what is the local area network it's on, and it's on VLAN 10. So one of the first things that happens when you turn on a machine is it will build this routing table on this machine right here. So then any packets that are being sent from it, that are being sent out, it's going to compare the destination IP address, in this case 10.2.0.5, and it's going to compare it to its routing table. And then it's going to find where it should send it. In some cases, it's just the local network. And then it needs to send it on its local network specifically to that specific MAC address. So, but other times it's going to be on another network. And remember, if it's sending to demo Pi 1, that's on the same network. But if it's sending to demo Pi 2 or 3, those are on different networks. So if it's going to another network, it's going to find what it's going to have is a longest match on the routing table and look at where it's supposed to be sent to. And in many cases, it's going to be sent to the default gateway. So that's what we're going to, for this one right here, since it is a network that's outside the realm of the VLAN 10, it knows already that it needs to send this packet, it needs to send to the default gateway. But what is the MAC address of the default gateway? And so what it will need to do is it's going to need to find out what the MAC address of the default gateway is. For this machine right here, it's 10.1.10.34. Its default gateway is 10.1.10.1, which is the IP address that's on this layer 3 switch. So it's going to try to reach this layer 3 switch. What it will do is it's going to send out an ARP request, an address resolution protocol request, because what is set up on that machine is a default gateway, and that default gateway is 10.1.10.1. But what it needs to do is, since it needs to send it to its local area network, it needs to find out the MAC address that it's going to send it to. And so what it's going to do is it's going to form an ARP request and send it out. And that ARP request is going to say, hey, what is the MAC address of 10.1.10.1? And it will send that out. It will broadcast that out. And what this switch is going to do is it's going to see that that's part of VLAN 10, and it's going to broadcast it out on VLAN 10 to include this trunk line, and it's going to make it up to this switch. This switch is going to take that in on VLAN 10 and say, oh, that's looking for 10.1.10.1. I will go ahead and reply to that. So it will send out a reply and say, I am 10.1.10.1, and here is my MAC address. And so now this machine right here is going to have a MAC address of the default gateway, and it's going to have an IP address of this switch over here, which is 10.1, or excuse me, 10.2.0.5. So it will have an IP address of 10.2.0.5, and that is the information that it's going to use to build the packet. One thing to note about when this ARP request and process took place is the frame that was sent through switch 2. Switch 2 recorded the source MAC address from that frame. And so it knows what port this laptop is on, and it is port 34. So it knows that this demo laptop is on port 34. It also, when the response came back from switch 1, so switch 1 had sent a response that came in on a port, and it recorded that as well. So it is port 47, and it knows that this switch 1, or at least the MAC address that came across that, is on port 47, and it will record that in the MAC address table. Now that it has the information, it's going to create the request. And so if this is an SSH request, somewhere in that payload is going to be the SSH information on making the request. This has an SSH client on here, and this has an SSH server on here. And the SSH server is going to have port 22 open on this device. And so it'll be listening on this device. And so what this demo laptop will do is it's going to send out a request to this, this switch over here, and it's going to be an SSH request. It needs to create that IP information on there. And the destination IP address is going to be the destination IP address, or it's going to be the IP address of this server right here. So it will include that in the destination IP address inside of that packet. So now it's formed this packet. But what it needs to do is it needs to send this packet across the local area network. So it's going to include the MAC address of switch 1 so that it can get to the default gateway on switch 1. It's going to be sent then across this Ethernet connection. This switch 2 will take a look at the destination MAC address and say, I know what port that is on. That came in on port 47. So I'm going to send it out port 47. I'm going to forward it on to that next switch. Switch 1 is going to receive that. It's going to take a look at the MAC address, the destination MAC address, and say, oh, that belongs to me. That is a packet that I need to do something with. So what it will do is it's going to then remove that layer 2 information. It does, remember that layer 2 has, I'm skipping a few pieces of information here. There's, there's TCP connections and there's other type of things that are going on with this. But it does have a trailer, and it's going to do the consistency check on that. So to make sure that this frame is correct. So there is some other actions that are happening here, but it's going to take this in and say, yeah, this belongs to me. I'm going to do the frame consistency check on here and process this. And now I need to figure out where it's going to go. I'm a router. I need to figure out where it's going to go. So I'm going to take a look at the IP address. It's going to reference its routing table, and it's going to see that this network over here, this IP address belongs to this network. I'm going to look for the longest match, and it's going to be the next hop will be this router right here. This is another Ethernet connection right here. So as Ethernet works, it's going to need to know the MAC address of whatever IP address it has in its routing table. It has some sort of IP address of who it's going to communicate to. Now it needs to know a MAC address. So it's going to do an ARP request. And then this router is going to respond back with the MAC address on this interface. Layer 3 switch now has the destination IP address where it's going to. In fact, it's got the whole packet that it's got. And then it also has a MAC address of the next hop that it needs to send this off to. Now that this layer 3 switch has that information, it's going to send that out onto this line destined for the MAC address of this interface. Guess what's going to happen on this router? This router is going to receive that information. It's going to take a look at the MAC address. It's going to do the consistency check to make sure it's correct. Once it determines that the MAC address, yes, that is destined for me, it doesn't need that information anymore. It gets rid of that layer 2 information. Then it can take a look at the IP address. It sees that the IP address is destined for this network. It looks up on the routing table to see what network that is and what the next hop is. And it sees that the next hop is going to be right here. It knows that this line right here, it needs to exit out this serial 010 interface. And so it sees that this line right here is a point-to-point protocol. And so what it's going to do is we have our IP header here, and we have our payload that's in here, or the data that's transferring right here, or in this case it's SSH, the SSH connection that needs to establish. And so what it's going to do is it's going to attach that layer 2, the header and the trailer, layer 2 header and trailer, but it's going to take the form of the point-to-point protocol, because that is the layer 2 protocol that's working on this network. And we know that the address of that is not a MAC address, it's all ones. And so it's going to send it along the line here, and it's going to send, since this is point-to-point, it's just going to make it over to this other destination. Guess what this router does? It takes that layer 2 information, makes sure it's destined for it, does that consistency check to make sure that it's truly destined for this router, and make sure that nothing has been corrupted along the way. Once it has that information, it's going to drop that information. And now it has this packet here. It's going to take a look at the IP information. It's going to look up into its router table, and it's going to see that it is destined for this network right here. And the next hop that it's going to go to is going to be this router right here. And so now what it needs to do is it needs to reform it'll still have that IP address header with it. There is something that changes in that IP address header too. There's a time to live and a consistency check with that as well. So there is some changes that happen with that IP. The data for the most part stays the same with this. It needs to add a new layer 2 header to it, a new layer 2 trailer to it. But in this case right here, it's an HDLC line. And so since it's an HDLC line, what the address in this layer 2 header is going to be just all ones. And it's going to add that to it. It will send it out its interface. This router will then receive it. It will once again do the consistency check, make sure that nothing has changed in it. It's going to take a look at that layer 2 header, make sure it is truly destined for router 3. And in fact sees that yes, it is. It doesn't need this layer 2 information in it anymore, so it gets rid of that. And now what it needs to do is it's going to take a look at this IP information and take a look inside the routing table, try to find its longest match. It's going to see that the longest match is actually a directly connected network. And so it knows it needs to send it directly to 10.2.0.5. So it needs to send it into the network for that. It will need to know what the MAC address is because this is an Ethernet network. And so what it will do is it will look up it'll do an ARP request, another ARP request, and say out there, hey, who belongs to 10.2.0.5? and that gets broadcasted out. And then this switch is going to reply back with the MAC address of the switch. And so now the router has the IP address where it's going to go to, because that's part of this packet that it's trying to forward. And what it's going to do is it now has a MAC address that it can put into this layer 2 header. Does the calculation for the trailer, and now it can send it into this network. It hits this switch, the switch gets it, makes sure that the layer 2 address is destined for itself, that it's supposed to receive that, and then it says, oh yes, I'm supposed to receive that, does the consistency check once again, and then gets rid of that information because it doesn't need it anymore, checks the IP, does a similar check with the IP, says, yes, this is destined for 10.2.0.5. And so then it doesn't need that information anymore. And then it takes a look at the payload. So we know that there's a TCP header or UDP header with these as well. So it's going to take a look at that information. And then in this case, it's SSH is the payload, and then it's going to establish that connection. That was all the communication that happened between here in a split second. It happens really fast, and it goes back and forth because if it's a TCP connection, it goes back and forth and establishes a connection. And so there's a back and forth that happens with this stuff really fast. It happens at incredible speeds. So that is the process and the interplay between layer 2 and layer 3 and how it communicates between these devices, despite these devices being possibly countries apart, thousands of miles apart, or it could be in the next room over.